Hello everyone, I am Naganisha from Data Science Branch. My USN is U23E01DS009 and my teammates are Shriyarika K and her from Information Science Branch. Her USN is U23E01IS026 and Purnima KB from Information Science Branch and her USN is U23E01IS015 and Suprita TS from Information Science and her USN is U23E01IS029. And here I am to explain about the problem statement of linear regression and decision tree for house price prediction. And here it is using for a real estate database built regression models to predict house prices based on the features like area, number of bedrooms, and location. And next here, introduction of the problem statements is house prediction is an essential task in the real estate industry, helping in investors, buyers, and sellers make data-driven decision with advancement in machine learning. Predictive models can now analyze vast amounts of data to determine housing prices based on the various features. This project focuses on two widely used regression models like linear regression and decision regression to predict house prices based on the factors such as area and number of bedrooms and crime rate and accessibility to highways. Here is the information and next code will be explained by all of us and the first part of the code is import numpy as np, import pandas as pd, import MATLAB pilot as PLTs from sklearn models selection, import train test so SPLT from sklearn pre-processing, import standard scalar from sklearn linear model, import linear regression from sklearn tree, import decision regression from sklearn metrics, import mean absolute error, mean squared error from sklearn database, import fetch California housing. And here is the explanation. And this code is importing here importing the necessary libraries for performing regression analysis using machine learning. Here is a breakdown of what each import does. First, NumPy and Pandas, where NumPy supports numerical operations, especially arrays and matrices, where Pandas handles structured data using data frames and series. And next, MATLAB pilot, where uses for the data visualization. And next, sklearn model selection splits the data into training and perform linear regression, where decision tree regression it is a decision tree based regression model. Next, evaluation matrices are mean, absolute error, and mere squared errors, where mean absolute error means which measures the average absolute differences between predicted and actual values. Next, where mean squared error means measures the square differences, penalizing large errors more. And where data sets are fetch California housing, loads the California housing dataset, which is often used for the regression problems. Thank you. Further will be continued by Sri Harika.
California housing loads the California housing dataset from sklearn.datasets. It contains features like median income, housing age, average rooms, etc. The target variable represents the median house price Next, the creating a data frame. PD dot data frame data columns equals data feature names means uh, here it converts the data set into a data frame with column names uh, from data feature names. Next, df price equals data dot target. It means adding the target column price adds the median house price as a new column in the data frame. Next, data pre-processing means here load build in California housing datasets from sklearn datasets, import fetch California housing, use custom datasets false, set to true if using a custom dataset. Next, built-in California built-in California housing dataset means
Into a futures X and target Y. Train test splits. The data is divided into a training set that is 80% and a testing set that is 20%. Using the train test split function, the model will learn from the training set and be evaluated on the testing set. Next, train test split and standardization. Manual explanation. Standardization ensures that all futures have the same scale, preventing a futures with a larger ranges from dominating a smaller ones. It's here steps includes a compute mean and standard deviation and transform each values. Then last step apply to train and test data. Then model training, which includes the linear regression and then decision tree regression. Linear regression means this model tries to fit a line that best predicts the target variable based on the futures. It calculates the coefficients from each futures, determining how much each future contributes to the final prediction. Then decision tree regression, it splits the data into a segments based on the future values and predicts the target by averaging the target value within the each segment. It is more flexible model that can handle non-linear relationships. Making these predictions, both models predict house prices for the test set. The predictions are sorted by YPRED linear for linear regression and YPRED tree for decision tree. Next, evaluating the models. It includes the MAE and the mean absolute error and mean squared error. Mean absolute error measures the average differences between the predicted and actual values. Mean square errors uh, penalize larger errors more heavily because it squares the difference between the predicted and the actual values. These matrices helps to determine how well the model is performing. A lower MAE or MSE indicates better model performance. Then visualization is explained by Purnima.
Hello everyone. I am Purnima. Lastly, the output of linear regression and uh, linear regression is visualization. You create a scatter point to compare the actual house prices against the predicted prices from the both models. Yep. Visualization, you create a scatter plot to compare the actual house prices uh, against the predicted prices from both models. Then each model's predictions are plotted as separate series of points. The linear regression prediction or y slash pred slash lin, decision tree prediction y slash pred slash tree. The closer the points or to the diagonal line, the better the model's predictions match the actual values. Scatter points that are further from the diagonal line indicate poor predictions. Lastly, the conclusion is by looking at the MAE and MSE and the visualization, you can determine which model performs better. Linear regression typically performs well when there's a linear relationship between the features and the target, while decision tree can handle more complex non-linear relationships but might overfit the data if it not properly tuned. Thank you.